Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So, in the Holy Grail of calculus, we see this identity here, and usually I've written it as f prime of x plus q of xh. But I thought that would be sufficient for anybody with reasonable intelligence to figure out the rest, but apparently it's not. So, what is the difference when do you know to use minus or plus? Well, it's actually very simple. If, for example, you have a curve like this, which is concave, which is not the same as the one that I use in this example here. Okay, I mean, this is concave up and this is concave down, right? So if it's concave up, you use the sum. So you'd say that the secant slope is equal to the derivative slope plus the difference, okay? And it shows you how to do the rest. And so you determine whether to use the sum or difference based on the concavity of f. If it's concave up, then you'll be using concave up, and depending on which side of the curve. So for example, if the tangent is negative, the tangent slope is negative or positive, that will also influence the sign of the the sign of these, not the sign, it'll also influence the operation between the tangent slope and the difference, okay? So, and why is this the case? Well, let's look at it. Usually, let's look at this example, which is different to the ones I usually quote or the ones I normally use. So I'd normally draw a parabola like this, and I'd draw a secant line like that. And so in this case here, the secant slope, if we normalize the slopes, the secant slope is greater than the derivative. So we would write f of x plus h minus f of x over h is equal to the slope of the derivative plus the difference, right? Now, something different happens when we have a curve concave down like this, right? So it's not going to be plus in this case, it's going to be negative. And the way you can check it is by completing the similar triangles and then testing to see, for example, if you say secant slope minus derivative, which would be this one here, secant slope minus derivative, then you're going to get an answer of 0.508, which is correct, okay? And if, for example, the tangent line is lying on this side of the curve, so if it were lying on this side, then obviously the tangent line would still be greater than the tangent line slope would still be greater than the secant line slope. I'm talking about in magnitude, not necessarily in terms of sign. And that way you'd know which form to use. So you can only use one of two forms, either a plus or a negative there. So I hope this has cleared this issue up once and for all. The Holy Grail works for any smooth function. Doesn't matter whether it's a polynomial, whether it's transcendental, whether it's exponential, any particular function will work. Okay, it's true as long as the function is smooth. So if you're not already a subscriber, become one. Follow me on academia.edu and click like. Tell your friends about this channel. Till next time, I'm John Gabriel. Goodbye.